So PVT conversion equations are used when you require, when you know certain parameters out of, you know, pressure, you know, volume of one state, you don't know the temperature in the other state, then you can use this relations to find out the other parameter which is unknown among pressure, volume and temperature in two different states, that is state 1 or state 2. Okay. So in any two different states, if any one of the parameter is unknown, then you can use these equations to know that parameter. So that is what I term it as PVT conversion equations, and have defined it for the all the 5 processes. And expansion process we have studied yesterday. In the expansion process, what happens? Your pressure gets decreased. So the process will be from 1 to 2 in such a fashion. That means it will go down as it is an expansion process, pressure has to reduce. Similarly, in a compression process, what happens? The pressure gets raised. So it should move up like this. It should move up so that it is a compression process from 1 to 2. Now we shall go for this particular problem. Everyone taken down it? A piston compressor compresses a gas in cylinder during a quasi-equilibrium process. He has not specified which process is of now. He has just said it is a quasi-equilibrium. It is a quasi-static. So another name for a static is nothing but the equilibrium, is it? So he says it is quasi-equilibrium. That means it is quasi-static process. The process in the cylinder varies according to the relation PV to the power of 1.4 is equals to constant. So first hint to guess the process is been given, that is PV to the power of 1.4 is equals to constant. So that is the equation given. So it's a compression process. That means how would be the expansion in the compression process? Which one should I take? 1 to 2 like this, or 1 to 2, just a minute, 1 to 2 like this, or it is 1 to 2 like this. So which one should I take? The first one or the second one for the compression process?
First one.
So first one, because in a compression process, what happens? Your pressure has to increase. So your state 1 would be here and state 2 would be here. Okay, that is why I have to take the compression process to be this particular thing here. Okay, fine. So let me keep this aside. Okay, fine. So he has given the relationship for the compression. PV to the power of 1.4 is equals to constant. So for this particular relationship, it implies that the value of K is equal to 1, or K is equals to 1.4 here. So which process is this? Can I guess which process is PV to the power of 1.4 is equals to constant, where K is equals to 1.4?
Polytropic.
Why you seem it as polytropic?
Because nothing is constant in polytropic.
Nothing is constant in polytropic.
Varies.
Okay, varies. So what is the value of K in a polytropic process?
N.
Arbitrary
N.
value.
It's just an arbitrary value. So he says 1.4 to be a polytropic process. Okay, fine. You can take it as a polytropic process. Let us assume it is a polytropic process. No issue. Okay, because he has said it as a gas here. Because gas does not have the value of 1.4 as its ratio of specific heats. Okay, it might have anything else which is not specified. But if he has mentioned it as air here, suppose if he has mentioned it as air and he has given the value as 1.4, then 1.4 is nothing but the ratio of specific heat of an air, then this particular process will turn down to be a adiabatic process, as the value of K is exactly equal to the ratio of specific heats. As of now, he has just mentioned the gas, so you can take it as a polytropic process, no issue. Okay. So in this particular process, K is equals to N is equals to how much? That is 1.4. What else is given in the problem? The initial pressure of the gas here is given. So again, you have to plot a state table, I guess. So state 1, okay, state 2, okay, pressures and volumes. What he has given? Initial pressure in the cylinder he has given. So it is 101325 Newton per meter square, which is atmospheric. And the initial volume of the cylinder is given as how much? 0.01 meter cube. Now, compute the work in compressing the gas to a final volume of, so this is the final volume, 0.005 meter cube. Okay, this is your final volume. So this is the question. So what you have to do? You have to calculate work done. Okay, you have to calculate the work done from 1 to 2, which is polytropic. Okay, any idea how to solve this problem? Any idea how to solve this problem? So P1 is known, V2 is known. First of all, how do I calculate work done from 1 to 2, which is polytropic? How do I calculate the work done from 1 to 2, which is polytropic? Yes, Amrut.
Okay.
So how do I calculate work done from 1 to 2, which is polytropic? What is the expression to calculate the polytropic work done from 1 to 2?
I don't know, sir.
Why, man, you don't know? You attended all the classes or not? Amrut.
Sir, previous classes I didn't tell you.
Hey, you have attended a lot of classes, man, but also revised all the formulas for the work done from starting from the isobaric process and till the polytropic process, and same at the class end. Otherwise, you'll lose your attendance, Amrut, okay?
Okay, sir.
Read it. That is what is the first priority for you. Do it now. Ashwita.
Yes, sir.
So how do I calculate the work done from 1 to 2, which is a polytropic process?
P1 V1
Exactly.
minus P2 V2.
P1 V1 minus P2 V2 divided by
N minus 1.
N minus 1. Now, in this particular equation, Benoy, in this particular equation, do I have all the values? There are some values which I should calculate and then substitute in this equation.
We don't have P2 value.
We don't have P2 value. So P2 value is not known. Everything else is known, I guess, right? P1 is known, V1 is known, and V2 is known. Even the value of N is known. So the only parameter you must calculate is P2. Any idea how to calculate the value of P2?
So we have a formula to calculate that.
Yes, we have a PVT conversion equation. PVT conversion equation for polytropic process. Okay, we have that formula. Where is that? So here it is. So for an isobaric, isochoric, isothermal, adiabatic. So polytropic, here is the formula. So you have to take this particular formula which says
P1 by P2.
What? Yes, P1 by P2
is equal to V2.
That is equal to
V2 by
V1
to the power of N.
whole to the power of N, that is equal to T1 by T2 whole to the power of N divided by N minus 1. So which two terms, this is your first term, second, and this is your third term. Okay, which two terms I should correlate so that I can get the value of P2 here?
Pressure and volume.
So so you have to correlate these two things. So that is P1 by V2, that is equal to V1 to the power of N. From this, if I extract a P, means I can that will be P1 divided by V2 by V1 whole to the, just substitute the values and give me the values. When 1 to 5 is your P1, V2 value was 0.2 0.005 divided by V1 value was 0.01 whole to the power of n value is how much? 1.4, I guess. Yes, 1.4. So the value of P2.
Hello, sir.
Yes.
Sir, isn't the
Rajat?
formula 1 minus n? I mean, P1, P2, V2 minus P1, V1 upon 1 minus n?
So both the things you can calculate. Both the things will give you the same value. It is just a change of the signs. That's it. So P2 V2 minus P1 V1 if you take it as 1 minus n. P1 V1 minus P2 V2 if you take it as n minus 1. So either of the things is correct. Always follow this.
Okay, sir.
Okay.
Okay.
So in order to avoid the confusion, let's follow a uniform way all over the class individually. So it is P1 V1 minus P2 V2 divided by n minus 1. That's it. Yes, Benoy, I'm waiting for your answer.
So you're asking me for the answer.
Yes.
Oh, I didn't hear. Okay, let me.
Okay. I told you.
So 0.37. Not sure.
0.37. Let's check with other people. No issue. Just give your answer. So 0.37.
No, so the answer is 267,398.27.
267 398.27.
0.27.
Okay, just check the answer, guys. Is this the right answer?
Yes,
With
yes,
everyone?
sir. Correct. Correct, sir.
Okay, so just, okay. As soon as I suggest you, as soon as you get a certain value, just update it back first into the state table, next into the formula, so that you will be having a clarity over the problem. So just update it back to the state table. It is 267 398.27. Note the values would be in Newton per meter square. Okay, all these values in meter cube. Yes, so the final step, calculation of work done from in a polytropic process, that is equal to P1 101,325 into V1 0.01 minus P2 267,398.2 into V2 0.00005 divided by 1.4 minus 1. Yes, guys, what is the value?
And I said not 9.3525.
Minus 809.35.
3525.
Two decimal places is enough. Let me check the value. Yes, it is exactly correct. Yes. So why minus? Can anyone just comment on this? Why it is minus? why the work output came in a negative value. Okay, even sometimes he will ask for the justification of your answer also. So it has a minus sign in the final answer.
Compression
So
is
what does-
taking place, sir.
So compression is taken place. Okay, yes, compression is taken place, but compression is nothing but work done on the system. Okay, that's why it is negative. Okay, because compression means, in the sense, you are working on the system, you are providing work to a system so that the gas gets compressed. So always it would be negative. Okay, clear with this problem? Any doubts? Any doubts, guys? Just a minute. Hello? Hello? Okay. So hope the things are clear for you for this particular problem. Any doubts? If are there, if in case, you can ask and discuss. Otherwise, we will move to the next problem, solve that problem, and end the class. Yes, guys, any doubts as of now in this problem? Rakshan?
No, sir.
No, sir. No, sir.
Okay, Amita. Understood?
Yes, sir.
Okay. So just take the next problem. Determine the total work done by a gas system following an expansion process shown in the below figure. So okay, this has been washed away. Okay, I will write it here, no vision. So it is 0.2, 0.4, and 0.8. Okay, if it is clear, yes. Okay, so here, how many of you say that I can solve this problem, sir? How many of you say, no, sir, I am not getting how to do it, just by looking at the problem? Anyhow, I'll be explaining you. Yes? So if you look into closely, how many processes are there in this particular diagram? I mean, PV diagram. How many processes, if you are there? Two processes, is it? So the one process being this particular thing, which is from A to B. Yes, A to B is one process. And there is a second process which goes from, again, where B is not your end state. So again, from B, it goes to C. Okay, from B, it goes to C. That is your process number 2. Okay. The hint is the work done by the gas from reaching all over from state A to state C, from state A to state C, is the summation of AB and BC. That means the work done from AB plus work done from BC. So you need to add these two work done in order to get your final work done. Okay. So first draw a state table for this. State table in the sense you have state A, you have state B, you have state C. Okay, and pressures and volumes. Okay, just draw a table like this. Do I know the pressure at state A? Do I know the pressure at state A?
50
So 50, what is the unit? So watch for the unit.
bar.
So 50 bar in
Bar.
the sense. So how should I convert this? So it is 50 into 10 to the power of 5 Newton per meter square, which is Pascal, correct? So I will be entering in terms of Newton per meter square for the pressure value and in meter cube for the volume value. So pressure at A is 50 into 10 to the power of 5. Any other parameter I can judge just by looking into the PV diagram.
Pressure at B.
Any other. Pressure at B, how much?
Pressure at B.
50
Same,
How
sir,
much?
50. 50 into
Same,
10
very
power
good.
5.
Because it is an isobaric
Isobaric.
process. Yes, very good, very good. Next, what else? What else we need?
Volumes are given also.
So volumes are given. This is in the meter cube. So kindly give me the volume. So volume at A is 0.2 meter cube, whereas the volume at B is 0.4 meter cube, and volume at C is 0.8 meter cube. That's all. Nothing else is given in the PV diagram, correct? Only this much. So using this, I must calculate the work done. I must calculate, carefully observe this, I must calculate the work done from A to C. That is your total process. That will be equal to work done from A to B plus work done from B to C. Now, it's a time to judge your processes. Okay. What is process A to B? Which process?
Isobaric.
Isobaric. So I'll be writing isobaric at the bottom. Okay. Isobaric. What is the process from B to C? What is the process from B to C? PV to the power of 1.3 is equals to constant is the slope parameter given. So, exactly. So it is a polytropic process. Okay. Now, work done from A to C is equal to, now see how we'll be interpreting the formulas. What is the work done, okay, from A to B, which is isobaric? Anyone? Work done from A to B, which is isobaric.
P into V2 minus V1.
Okay. P into V2 minus V1. But you have A1 is nothing but A here and 2 is nothing but P. Can I just write P into VB minus VA? Just an implementation of the notations, that's it. Okay.
Yes, sir.
So it is nothing but P into VB minus VA. I got the value of work done for isobaric. Now it's time for the polytropic process. What is the work done from B to C, which is polytropic? Can I just write directly PB VB minus PC VC divided by N minus 1?
Yes, sir.
Clear? So if there is a polytropic process from 1 to 2, then how will you calculate the polytropic work done? It is P1 V1 minus P2 V2 divided by N minus 1. For B to C, it is PB VB minus PC VC divided by N minus 1. As simple as that. Okay. Now, in this whole work done expression formula, which you have just framed now, what parameters is unknown? So that which is a hindrance for me to calculate that particular work done. Which
PC.
parameter is unknown? PC is unknown. Is there any means so that I can calculate PC? Is there any means so that I can calculate my PC? So PC is unknown. Yeah? Is there any means? Exactly. So you know that B to C is your polytropic process, correct? So B to C is your polytropic process, and you can use the PVT conversion equation for the above process, PVT conversion equation for a polytropic process is given by PB by PC, that is equal to VC by VB whole to the power of n is equals to TB by TC whole to the power of n divided by n minus 1. Any confusions here? Just have replaced 1 with B and 2 with C, because the process is from B to C, not from 1 to 2. Yeah?
No, sir.
Any confusions here?
No, sir.
Very clear, right? So in that, I can use this expression again. So it says PB divided by PC is equals to VC divided by VB whole to the power of n, which in turn implies I need the value of PC. So PC is equals to PB divided by VC divided by VB whole to the power of n. You know all the values. Calculate the value of PC. Once you calculate the value of PC, substitute all the parameters in this expression, you will get what is the work done from A to C, which is your final answer. Any difficulty in doing the problem?
No, sir.
Okay, just try. Meanwhile, I'll be marking your attendance. Okay. Give me the answers, man, first. Class 15. Okay. Abdul Rahim. Rahiman.
Yes, sir.
Abhinav. Okay. Abhinav. Abhinav. Next is Adarsh.
Present, 0.0306 into 10 power 6.
Okay, which one, Karthik?
PC,
PC
sir.
value?
Yes.
How much?
2.0306 into 10 power 6.
03. Always keep only 2 decimal points after your decimal. That's enough. Okay.
Okay.
2.03 into 10 to the power of 5. How much? 2.03 into 10 to the power of
6, sir.
6. Okay, 6, 20 bar. Fine, no issue. So it is Newton per meter square. Once you get the value, update this back. Before I update back into the state table, others confirm the answer. Ashanul Mustafa, Reza Muhammad Kuni.
Yes, sir.
Okay. Next is Akshay. Next is Amit Yaslahari.
Present, sir. Akshay present.
Akshay present. Oh, what man? Today is your first class or what?
Second, sir.
I mean to say you have attended the introductory class. What, Akshay?
Present, sir.
Yes, man, Akshay, got you. Hope
I have some network issues, sir.
Got it. No issue. Okay. Amit Yaslahari.
Present, sir.
Okay. Next is Amrit.
Present, sir.
Okay. Anvit. Ashwin. Ashwita.
Sir.
Next, D'Souza Benoy.
Present, sir.
Next is Fahad. Fahad. Faizan.
Present, sir.
Just check for the answer, man. Whether answer given by Karthik is right or wrong. Gaurav.
Present, sir.
Next is Gautam. Javel.
Present, sir.
M. Karthik is there. Fazil.
Present, sir.
Sihab. Muhammad Sihab. Muhammad Sihab, not there. Tausif Ali. Muaz. N. Suraj.
Present, sir.
Were you absent for the last class, Suraj?
Yes, sir. Placement only.
Placement was there. Okay, fine. Nafa Abdul. Next, Amita.
Present, sir.
Nandish.
Present, sir.
Nartan. Nartan. Niharika Rao.
Present. Sir, Nathan present, sir. Network issues, sir.
Okay. Nishchit.
Yes, sir.
Nitin George.
Present, sir.
Next is Omkar. It's not there. Prathan.
Present, sir.
Pratish Suvarna. Pratish. Not there. Pajit.
Present, sir.
Rakshan is there.
Present, sir.
Ramdas.
Yes, sir.
Ranjit. Okay. Ramdas, what's the issue, man? Every time you join by another link, why you don't receive my mail every time?
Sir, first I paid half the fees. Then the next time I
Acha.
had to pay the other half. Uh,
Uh-huh.
I couldn't fill the Google form again with the same email ID. So I used another email ID.
Acha. Okay, fine. Sabit.
Present, sir.
Sagar is Acharya.
Sir,
Shahzad Abdul.
Sir, Saga present.
Okay, man. Shahzad Abdullah. Shashank PC. Shetty Sujay. Shetty Tejas. Shravan Kumar.
Present, sir.
Shriraj. Next, Sumant. Varun S. Vigneshwara. Amit Sangolli.
Yes, sir.
Nilesh B. Merkel.
Present, sir.
Prajwal Sandesh Rachan. Anyone there? Okay. Varun. Adarsh P.
Yes, sir.
Adarsh is there. Sampreet and Mohammed Amin. Amin, yeah. Why were you absent for the last class? Okay, but you missed the classes. Okay, fine. No issue, man. But please be updated since we are solving problems. Okay. Yes, guys. The answer given by Karthik is right or wrong?
Hello, sir.
Numan. Forgot you. Your name is there, but I forgot.
I'll send my name and you.
Okay, man. Fine.
Thanks.
Okay. Yes, man. So answer given by him is right or wrong? Any corrections in that?
Correct, sir.
Correct. Okay. What about the work done? Calculated? Very good, guys. Very good. Work done, calculated. If you have any problem while calculating the things, you can discuss one openly because your doubt will be some of the clarifications for the other guys also. 2.5 into 10 to the power of 5. What is that? The work done? Amin, is that the work done which you have posted? Because I don't have an answer here.
Yeah, I'm not sure, sir.
Not sure. Let us check, man. I'll just write it here. 2.5 into 10 to the power of 5 joules. So this is the answer given by Amin. Just check, man, whether it is right or wrong. Positive? Okay, because it is an expansion process, you'll get a positive value. One 1752000 is the project's answer. 1752000. So approximately 1572 kilojoules. This, which one is correct? Whether it is so
0.25
difficult.
into 10 power 6
2.25
into 10 power 6.
into 10 to the power
2
of
point-
6.
Yes.
Okay, 2.25 into 10 to the power of 6 joules. So this is another answer. So Sagar says 22.53 into 10 to the power of 5 in the sense, again, yes, Sagar's and Karthik's answers are matching. When Prathan is giving the same answer. So 3 had upvoted with me, the third answer. All are getting the same answer or what?
Sir, we are getting WB value negative, so we shouldn't consider the negative.
You are getting a WB value negative.
Yeah.
WB to C. So
Yeah,
B
sir.
to C cannot be negative. Why? Because see, B to C is an expansion process and it will be work done by the system. So if it is a compression process which is work done on the system, it would be negative. So eventually it should not be negative, B to C.
Oh, yeah, okay, sir.
Just check whether you have taken the formula right or wrong. Okay?
Yeah, okay, sir.
Okay, so how many of you are getting the same answer, 2.25 into 10 to the power of 6, which has a comparatively higher majority than the other answers? Nilesh, what's your answer?
Yes, sir.
Suraj, what's your answer? What about Niharika, Namita, Nashad? What's your answers?
Sir, I think I went wrong somewhere because I'm not getting the same thing.
Okay.
I'll just go through it once.
Okay. What about Nashad?
So one
Sir, I
clarification
got
is
a 2 point same answer.
Okay. Nashad?
Yes, sir.
What's your answer?
I got 2.03, but I'm checking it again.
Into 10 power?
6.
That's correct.
Like, I'm not sure.
2.03. Because many are getting the same answer. Yes, even Niharika, Jebel got the same answer. Okay. So hope we'll get the same answer on everyone. And how about the problems? Are easy understanding it?
Sir,
Yes, Karthik.
the work done from A to C, no, sir. There is a P there.
A to C.
what is there is a p value, no sir? Which one to substitute, sir?
Which ones to substitute? See,
Is
you
it
can
15?
yes, it is 50 definitely, because p value is from p value is regarded. Just a minute, let me take a pen. So p value is in regard with the process A to B. Yes or no? So the process A to B is just a isobaric. So because the value of PA and PB would be same. So PA is equals to PB. PA is equals to PB. That is equals to P. So either of the value can take. So eventually I will just substitute as P because it is known thing. Pressure remains constant over there.
Okay, sir.
So how are you feeling? Problems are difficult, tedious to understand, easy, solvable? What it is? So I suggest you see all those 5 processes. What are the K values? How does it look on a PV diagram? What are the work done expressions for all the 5 processes? And what are the PVT conversion equation for all the processes? If you just remember those, your entire 3 modules is in your hands. So even you'll get noticed that even your module 2, even your module 3 is based on all these fundamental concepts which we are learning. All the 5 processes, their work done calculations. Okay. So have a hold of it, keep practicing, and the classes will be interesting. Okay. If you have any doubt in between, immediately raise it and solve it so that you get cleared, and the further classes you will be in a position to solve those problems. Okay. In the next class, so how many problems are there? Okay, many are there. We shall solve anyhow in the next class. Okay. So till then, take care. Okay. Have a great Sunday tomorrow. Enjoy yourself, and we shall meet up in the next week. Okay. Take care, guys.
Thank you, sir.
Yeah.
Thank you, sir.
Sir,
Yes.
sir, this is Ramdas.
Ramdas, yes, man.
Sir, I'm not getting your invitation mail to this account. Can you add this account to your list?
So the list will be updated by your class advisor daily, man. So I cannot update it. So you have to consult your class advisor
No,
for that.
because I'm getting mails for every other subject except yours. That's why.
Because I follow the list given by your class advisor, and
Okay, sir,
she will be
I'll let
updating me daily. That's why.
I'll let you know.
Okay.
Thank you.
Yeah.